It's very important for us DeFi users to understand how decentralized exchanges work, how DEXs work, and that's what we're going to do in this video. And if you're a developer or a user and you want to understand how things work behind the scenes, I think this video is going to be helpful for you. And yeah, just to make the clear distinction, we're going to be building a DEX in this video, and we're going to explain how a DEX works, not a SEX, not a centralized exchange such as Binance, FTX, or MTGOX. You know that these exchanges should be are risky, as you have seen in the news recently, and yeah, it's a story that repeats over and over again because they are not backed by blockchain. They are not backed by these decentralized network computers such as Uniswap, Pancake, Balancer, or even SushiSwap. Also, in the case of SushiSwap, we're going to understand a little bit more how a DEX works, so you can understand what the like the centralization opportunities are, or centralization points are, so you can like navigate into this knowing exactly what is centralized and what it's not. We're going to make a fork of Uniswap version 2, and we're not working on version 3 because that's closed source, and Uniswap version 2 is open source and you can use it whatever you want, and also has a very permissive license, which is very nice. That's why we're using Uniswap version 2. Now into the contracts, we're going to talk about the three main smart contracts of Uniswap: the factory, the router, and the pair. We're going to discuss each one. First, the pairs. The pairs is the most important contract because it allows swapping and also gives an oracle price. It also can define a price, as we said, it's a market maker, and also it allows everyone to deposit liquidity and earn a yield from it for every a transaction. For each transaction, you can earn a reward, and also grants LP tokens, and it's an ERC20. This is like this is how you can demonstrate that you have deposit liquidity and you can retrieve back your liquidity. And also as we said, it provides an oracle price based on the function x times y equals k. We're going to talk about this in a moment. The factoring is very important because in smart contracts and in the programming jargon we call factories to contracts that makes other contracts. We also call them chefs or master chef, but it's usually factory. So a factory is a contract that is allowed to create another contract, and the factory is a contract. The Uniswap factory is a contract that creates pairs. So if you want to create a new pair, you go to the factory and you give them 2 tokens because and the pairs have 2 tokens, so you can make the swaps, and the factory will create a new pair for you. That's the job of the factory. And the router is really at this point, just with the pairs and the factory, you can do a DEX. That's all that you need. But a router is an interface on top of the pair and the factory that simplifies the interaction for the user, also prevents front run. So it helps us, giving us just a better user experience or developer experience, which is very nice. And most of the time we use routers to interact with Uniswap or whatever DEX, but you can do it directly with the factory or each pair. Now, before going into the code, I would like to discuss a couple of things. The two main functions of a DEX using V2, Uniswap V2, which are add liquidity and swap tokens. And I think that if you understand these two functions, you will be able to understand the rest of them. That's why I would like to focus on these two functions. So first, on add liquidity. Add liquidity works like this. You deposit 2 tokens, for example, ETH and BTC, or the token that you created and USDC, whatever, and you give the router these 2 tokens, and the router, if the token is if the pair, the combination of tokens doesn't exist, it will go to the factory and create a new pair. So there's only one pair for each pair of tokens, or one contract for each pair. And if it already exists, so it will deposit the 2 tokens on the already existing contract. So there is one contract for each pair of tokens in Uniswap or any fork. Now the second function is the swap exact token for tokens. And there are many variants of swapping tokens in Uniswap. They always start with the swap keyword. You have swap exact token for token, swap exact ETH for tokens, swap token for exact tokens. There are all these combinations, but they are generally the same. In this case, swap exact token for token. So in this case, you're going to swap the exact amount of token A for the price of token B current in the market. And you do that by depositing the A tokens to the router contract, and the router contract will be in charge of looking for the pair contract on chain and swap it for the B token if the pair exists. And yeah, that's how it works. And I would like to discuss a little bit more about this because this is a little bit complex, I think. So I'm going to try to simplify the parameters of this token, of this function as much as I can. So especially these two parameters that I think are very important to understand. So first, amount int is the amount of tokens that you want to deposit, and amount out min is the slippage, or basically at least how much token you expect to receive, because as you know, the market, the blockchain it has some like lag time, so it's not like when you call the function automatically it's going to be executed. So the price during these seconds or minutes can be changed. So you need a way to protect from that. We're going to talk about this in a moment. In a moment. The path is the swap. The Uniswap allows you also to not only make a swap from token A to token B, but you can also make in one transaction using the router. You can do, okay, I want to swap token A for token C and token C for token B, just to have the opportunity to make a arbitrage, just to catch up an arbitrage opportunity, which is nice. And 2 is who is going to receive the tokens, and we don't have access to this in the UI, but in the contract level, you can deposit from one contract and the token will be receiving another, which is nice. And the deadline is how much time you are willing to wait for the transaction to be executed. Now let's talk about these two, the amount out min, the slippage, and the path, the routing. So the amount out min is this, you can set this in the UI. For example, in this moment, you could, in this picture, if you want to transact it for DAI, you can transact 0.1 ETH for 120 DAI. And if you set up a 1% slippage, you can transact. You are saying that you're willing to, even though the market price is 120, you can when the transaction executes, if the price of it drops until, for example, 118 or 119, that's a 1% slippage, you're willing to take it. You're willing to take it if the new price is 118. Of course, if the price stays the same, or even if it goes up, you will get the better price for you. You are just saying with this 1% slippage that you're willing to take up until 118 or 119 DAI for your 0.1 ETH. Now, in terms of the contract, you pass this in weight, not in a percentage. This percentage that's shown you on the UI is just to make it easier for you, but you can at the smart contract level, you pass this in way, like in a fixed number, not a percentage. And now about the path. we also call this routing. You can, as I said, you can catch up with arbitrage opportunity. If you want token A to convert it to token B, you can convert for token C and then for B, so you can have an arbitrage opportunity if the liquidity pools are unbalanced. So you can balance them out, which is nice. And it's very, yeah, and we have also something very important is this routing is done off-chain. So the smart contract allows you to do routing, but it doesn't do the routing for you. So when you go to Uniswap and you see this path, and this routing path is not like you're going to, it's not like you're going to, that's calculated from a smart contract. That's done off-chain, and the opportunity is presented to you on the website, and you can decide to take it or not. So now we're going to start with the smart contract. In this video, we will launch a factory and the router contract. As you know, the pairs will be created by the factory, so the only two contracts that you need to launch is the factory and the router. Also, we're going to launch 2 sample tokens, and we also create a sample HTML and JavaScript vanilla. Just a simple dApp for us to use. And we also do a swap using this basic UI just to test everything out. So now let's start with that. As we usually do in this channel, now we have here a step-by-step guide blog post that you can follow along with me. And this is very long, usually it's not that long. That's why I added a table of contents here. Now we're going to start by creating the first launching the factory. And to do this, you're going to need in your MetaMask some Goerli ETH on testnet. I'm going to leave links here for MetaMask and Français if you want to install them and get the free Goerli ETH. And also, if you want to do everything we're going to do in this video, which at the end we're going to make a front end, you're going to need this Node.js. I'm going to leave here the links on Linux, but you can do that too on Mac OS or Windows. So let's start by launching the factory. So we're going here and we're going to select all the code and we're going to put it on Remix. So we go here to Remix. We're going to create a new factory contract and we're going to paste it here. We are going to compile it using the 5.16 version, Solidity version. So there you go. Now here I have some other contracts here. We're going to delete them. I think I also have here, yeah, no, that's not good. So you make sure you select MetaMask here, then you select the factory here, and you're going to need the fee setter address. And what is the fee setter address? So the fee setter address is the one that's able to set the 0.3 fee on Uniswap that can be changed by the protocol itself. So at the beginning you can set it for the other for yourself. What did Uniswap is they have this multi-sig wallet and then they escalated it to a DAO. So that's now this is governed by the Uniswap token, which is super nice. Okay, now that we launch this, now we're going to continue with the router. So the router is very tricky, and because I have 2 smart contracts, and I told you that it was only on. So in Uniswap version 2 that was launched in Mainnet, there's only one router contract. But in here I have 2 router contracts, and why is that? That's because there was a change in there was a change not in Solidity, but in the Ethereum network, that there was a restriction added that now the smart contracts cannot be as big as they were before. So now if we can't now redeploy the code of Uniswap as it was deployed in the past. And yeah, that's why what I did, the solution that I found to do this is just to separate the code into 2 parts. By the way, here you have to, for the router, you have two addresses as parameter, the factory and the wrapped it. The factory you can grab from here, from the contract that we just deployed. And I left you here the Goerli address in the blog post, so you can use that. So you paste it here, and there you go. Now this is the first half of the router that's only handling the liquidity parts, add and remove liquidity, and the other half that we're going to launch now, which is basically the same, that allows you to do the swaps. This is the router swaps. And so I did it this way because this was a commission that was freelancing, and I got asked to do this router that was going to be launching mainnet, because if you launch this in another blockchain, for example Binance Smart Chain, I think you can do it in one block. Is going to fit all the smart contract, but that won't be the case on mainnet. So I was asked to do this router that was going to be launching mainnet, and also we needed to add a couple of extra features. So that's why I needed a lot of extra space, because there are some alternatives to this way of doing it. You don't have to like separate this, but since we needed to add a couple of extra features, I needed a lot of space, and just compressing it or doing these alternative things wasn't. Oh, sorry, it's not the. We also need the wrapped it and the factory. It's not going to be enough. So yeah, that's why I decided to do it this way. So at this point, these three contracts are the only ones that you're going to need: the factory and the router, but I divided it into two. And yeah, that's it. Only with this contract, now you have a full functioning DEX. But to be able to test this out, we're going to launch two tokens. We're going to have this. You can use this simple ERC20 contract to test that everything is working good. This one I did it with the latest 3D version. So we compile and we launch, but we're going to add some, put the name, the symbol, and 1 million supply. I set this on the constructor so it will be easier. And we're also going to launch a token B, like so. And there you go, token B. So if you're liking the video, if you're learning something, hit the like button. If you have any questions, leave it in the comments. We'll read every comment. And if you any ideas or whatever, you can also join our Discord. We have an English channel. This channel is mainly Spanish, but we have also an English channel, so you can send us messages. And yeah, thanks for watching so far. Good to have you here. And subscribe if you want to learn more about NFTs, DeFi, oracles, layer 2, play to earn. We cover all of that in this channel. Okay, we're going to add this to MetaMask, the tokens that we just launched. So we're going to add in token A. There you go, token A, 1 million tokens. And token B. There you go, also 1 million tokens. And now we're going to do the front end. So in order to do the front end, we're going to create a new folder. We're going to get into the folder and we're going to open our favorite text editor here. And yeah, we're going to create a new folder. Inside that folder, we're going to add this JSON ABI file structure, all these files. So what are the JSON ABI? So as you know, you have your contract that's deployed in a decentralized network of computers, and you have your front end doing with HTML, JavaScript, or whatever, and you need to interact with this decentralized network. And as you know, every smart contract has functions and parameters to interact with it. So the JSON API describes all the functions and all the parameters for every one of them. As you can see, you can find them here in the Solidity compiler tab. First, you compile your contract, and here you select whatever you want. So here the simple token is the one that we're picking here for the ERC20 file. Now we do the same for the factory. So we go here, we recompile using the correct compiler version. Once it's compiled, you select the factory here, you copy the ABI by clicking here, paste. The pair is the same. As you know, the factory launches the pair, so the pair ABI is inside the factory, and then we do the same with the liquidity swaps, but we have to select 066 compiler version, compile, select the router liquidity ABI, here you go, and finally the swaps. We compile here, and we select the router swaps here, copy and paste here. There you go. Now we are ready to build the rest of the front end. As you know, you will need an HTML file, and also you will need a blockchain. I name it blockchain stuff. You can name it whatever you want. A JavaScript file. So for the HTML part, here is the code. The simplest code that with a full functioning router. Here accepting 2 tokens only, and here in the HTML you put the tokens, and also for the proof, for swap, for liquidity. This is this is where you define it, and a little bit of JavaScript that's going to point to the blockchain stuff, file. Also worth mentioning that we're using Web3.js, as you can see here. Actually, you shouldn't use a CDN. You should use your own local file, but this is just a simple example, just starting point, and there you go. So in this blockchain stuff file, you're going to need a couple of things. Only this. You will only need to modify this, all the addresses. So you can find them in the deploy contract part. It's the factory, liquidity, router liquidity, router swaps, token A, token B. There you go. Save. And this is all you need to change. For the rest of the code, I'm going to explain it briefly, give a little bit of a tour for you, so you can then focus on what you want to learn from here. So the first part, here is, as you can see, very important. We are using network number 5 because we're using Goerli. Goerli is the network ID 5. If you want to launch in Ethereum Mainnet, it will be 1. If you want to launch in Binance Smart Chain, it will be 56. But yeah, we're using 5 because we're using Goerli. Now, all this part up until here is initializations. So what you want to initialize is make sure that MetaMask is installed and the user is connected with it, and also you will need to initialize every contract. And what you need to initialize to interact with a contract is 3 things. You will need the address, which are here, and you will need the network ID, which is here, number 5, and you will need the JSON API, which we define here. With these 3 things, you can initialize and communicate with the contract using any Web3 JavaScript library or any library in general. And yeah, that's what we do around here. We initialize each contract, and at the end, we call this is all done in this load up function that loads everything. And once everything is finished, we have 2 callbacks. First one, if on contract init callback. Oh, sorry. Oops, I did a mess. Yeah, here we go. So once everything is launched, you have 2 callbacks. First one, we usually divide it in 2. Once every smart contract is loaded, we have a callback, and once the user connected to MetaMask, we have another callback. Why is this? Actually, this is the first one, the contract callback, and this is the wallet callback. So for if you want to make a good user experience for your user, you will want to him to navigate the website without connecting with MetaMask. So user can go to the site, navigate, and if you want to interact, he should be able to see a little bit of what's going on in the website, and he wants to interact, then you can add like a connect button so he can connect. If you just spam your user with a MetaMask connect button, since from the beginning it's not like a very good experience. So yeah, that's what we're doing. And in this case, we're going to display, for example, token prices in the contract callback, and user balances when he connected. So it's a better experience. Of course, this website is super simple, but this is like the foundation where you can build a better website. Also, I would recommend you launching with just JavaScript or HTML because it's too hard. And if you want to do the cool stuff, like the good UI stuff, like the tricks to make everything looks better and more responsive, I would recommend you to use either Vue.js, AngularJS, or the most used in blockchain which is React.js. So yeah, I'm just using JavaScript vanilla because it's easier to explain, easier to understand, and it's generic. So if you understand this, you will be able to do this in whatever front-end library that you use. Okay, now, and at the end we have the functions, for approve, add liquidity, approve token swaps, and the swaps. All of that is here at the end. This is the function that connects to the front end, to the smart contract, from the front end to the smart contracts. Yeah, that's it. I think we're ready to try this out. And to try this out, I would recommend you using using npm node and installing the light server like this. But I already have installed, so yeah, I'm just going to cancel this and just put this in terminal. And this is our web. As you can see here, we have the liquidity and the swap functions. Let's start with liquidity. First, we're going to approve both tokens, 1000 token A. Yeah, I'm just going to speed this up a little bit, just in case. And also we have token B, which also I'm going to speed up a little bit here. Oops. As you can see, I'm approving 1000 token A and 2000 token B just to make it a little bit more spicier. So 1 token A equals 2 token B, and 1 token B equals 0.5 token A. So once the token B gets approved, I'm going to put 1000 here and 2000 here. So yeah, we're going to also speed this up a little bit just so we don't wait too much. There you go. And yeah, so as you can see in the swap part, since we still haven't added any liquidity, we said you can swap, please add liquidity. You can go here to the code and you can find how did we know that. Oh, it's because there is no pair address so far. So when we add liquidity, the factory will create the pair, and the pair will be calculated from will be known from here, from the UI. And now that we refresh, as you can see, 1 token B equals 2 token B, and 1 token B equals 0.5 token A. And if we make a swap, for example, I want to swap 100 token A for it will be 200 token B, and two things will happen. One is that, as you can see in my wallet, I sent 1000 token A and 2000 token B. So I will deduct 100 token from here and will add about 200 token here. So let's do that. Oops. I approve 1 token A. Now I'm going to do the actual swap. You don't have to do this, by the way. I'm just doing this, but I'm spending a lot of ETH, like wrapped ETH to do this. But yeah, you don't have to add a lot of to speed up the transaction as I'm doing. Yeah, it's just to make this video faster. So yeah, as you can say, now it will be 100 will be deducted and around 200 will be deducted here, and also this will change the prices. So the prices of token A will be lower now. And yeah, while we wait, I invite you again to like this video and subscribe. And yeah, to if you are learning something, and also give a like, especially for this video, if you especially like more videos about DeFi, and also leave a comment. Also, I think it's we could like go very deeper into this version 2 decks, because it has a lot of interesting stuff. So yeah, if you like that, leave a comment. And yeah, so let's see. Yeah, as you can see, we deducted 100 token from token A, but we got around token 200 token B, because yeah, this is the new price of the token. Is we didn't get like 200 exactly, because the x times y equals k function. But yeah, that's it. And if you refresh, you can see that the new tokens got updated. Also, if you want to do this differently, I would recommend you not to use Remix directly. If you want to add more features like I did, what I did is I used Hardhat, but you can also use Foundry, or you can also use Truffle to make a lot of new features. For example, test your feature testing, or use or having your work stored in GitHub more easily, which is super nice. And yeah, you can do it more easily with Hardhat or Truffle. Also, I would recommend you, of course, as I said before, using Vue, Angular, or React. And if you don't want to separate the swap and the liquidity, I would recommend you to use to either compress your smart contract. You can compress when you compile your smart contract, or and I also recommend you to maybe remove a couple of stuff, such as remove events, or remove certain repetitive functions which Uniswap has. You can launch Uniswap version 2 that way. That's another way of doing it. So yeah, thanks for watching, and see you in another video. Bye.